my interview is about an hour and a half. Probably just do a warm up. One thing it's with the warm up is that don't take it too seriously. I think just like if you warm up like pre-basketball game and you miss a few shots, that's okay. The sample size is a lot smaller, just like 2 questions, I believe. Yeah, up to 2 questions. And then so like even if you fail both questions here, there's no bearing on like your actual interview because it's pretty unlikely that they'll ask one of these 2 questions. So the whole purpose of the warm up is just to get my brain to activate the spatial thinking part of my brain. So then you kind of get all the careless mistakes out of the way. Yeah. Anyway, yeah, so I guess I'll just warm up and yeah, let's just play with this. Return an array of all characters that show up in all strings within the words. I see. You can in any order. So, including duplicates, that's the hard part. So like I kind of want to use like a hash map, but I'm not sure what I want to do with it. If I go through all of these and I put all the letters in the hash map, and I count how many B's there are, then like B, and then that doesn't exist. The brute force way is just for every letter and everything, then check against everything else. Like what if I sort it? Is there any, if I sort all these strings, is there anything there? Yeah, if I sort it, then it'll be like A, B, or whatever, right? And then like A, B, and then E, L, L, O, R, or whatever. And then I just go A to Z. So like, so you have a max of 26 iterations for still ON. And then so if, so my pointer is just going to be at like A, and then if I iterate through A and well, yeah, so I'm gonna do this and I'm gonna pop it, right? And I'm gonna pop it, and so if it equals to my target letter, so my so more formally like words 0 is gonna be my target, and then for like element in range of like, you know, length of the words, then let me just write it out in code. Then like if element 0 is like target letter, then actually I want to use index because I'm not too confident in the, yeah. So let's say if words of I of 0 is target letter, then we want to pop it. So maybe like a pop, but if it's not, I don't pop it. And if I reach the end, so I'll have some running detector to say exists in all equals true by default, but like if I find something where if words I of 0 is not target letter, then go ahead and exists in all equals false. Now break out of it, and then also yeah, then words I dot pop 0. Because it's a string you can't pop, so you have to use this one, and then let's see. So I pop, and then I pass, and then let's do B. So I pop, and then I find that. But then what if like, can you have a case where no. I was thinking if you could have a case where like you, let's say have B here, and then like you pop it, and like it's actually like showing up here. Like, because for example, like if, but then you kind of can't, because for any letter in the English alphabet, let's say this is alphabetized and they're all alphabetized, even if you have like B, C, D, E, A, B, C, D, or whatever, oh, I guess in this case, then you can't, because B exists in both, but then you will just pop this and don't think it exists, so. Okay, so that doesn't work. I feel like there's some like really simple thing. That I'm missing here. Words dot length is only 100, so it's only. Can you just brute force maybe? But then how do I brute force like? Or what if like you have a table of the, you know, Bella, and then you do like so you construct this mapping, and then for word and words, you maybe A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Split. I believe that. I'm not sure how to turn it to. Okay, then I can just do like in or set or whatever. If then switch these maybe. So like for alphabet and alphabet basically, then I just want to do for word and words. And so if alphabet, like if this like A is in the word, then we go ahead and say actually want to remove it. How do I remove it? Find index of Python. Lowest index. Okay, that's actually what I need. So dot index. So it's a string function. So if alpha in word, then so we just remove it. So if I loop through all the words, and in every single word this alphabet is in each of the words, then I would exit this loop with exists true. So if exists, then answer.append alphabet, and then you just return the answer. String has no pop. Oh, that's quite. Okay, for okay. If it is in Word, then instead of pop, then so for example, if this was found in index 2, we would exclude 2, and then continue from there. So strings you can add, I believe. So let's see what the next error is. EL, but not LL. So maybe I just store some extra information like what is the count. So this won't be the answer anymore. This is just like data. and then I kind of want to see because then no, because then this count accumulates across. I kind of want just to see like per alphabet. Actually, I guess the problem is like not that. It's I didn't remove enough things, right? So if so I just need to do something where it's like but if I pop it like this, then I should probably go backwards. So why does that matter? Oh, I don't want to pop it actually. So this was what I had previously, and then so if Basically, I want to check if all are empty strings. If all empty strings, then we're empty. Have a traverse at the end, and how do I do this? Actually, yeah, non-empty is false. If I find something, then non-empty is true, and then I break. Otherwise, the entire thing is empty, and non-empty is false, or empty is true. Okay. All right, bounded strings are those that have equal quantity of L and R characters. Find a bounded string S. Split it. Given a bounded string S, split it into maximum amount of bounded strings. So this is like DP or DFS, not sure which. Is R itself is not a bounded string, so oh, I see. So it's not consecutive, it's like this. What if like I start here and then, you know, I just count how many R's I have, and then if I find L, I just subtract, like net R equals 0, and then for I in range length of S, if then big R, then net R plus equals 1. If net R is 0, then we increment 1, and then so same thing here and same thing here. Now, I don't know if this greedy thing will work because I do this, and then what if so suppose there were L, well, we can't. Like if there were two L's here, like RL, RL, or RR, LL, then that would RL, RL would terminate, or RR, LL would terminate. And then like, so if I have 3 R's and 2 L's, I need another L to terminate, but then this R stops it from happening. Like if it's L and it terminates, then by definition, that's the smallest atomic balance that we can do. We're given the assumption that the string is balanced. What about like LR? Yeah, so I can't, well, it doesn't matter, right? Like we just start negative and then we just add back to 0. Can you have like, can you reverse the polarity? Like you have 2 R's and then like 3 L's, then you still split it and then now your L leads. Because then if you're a balanced string and you have some substring before your current index annihilate each other, then like, and you start with an L, then you're guaranteed to have at least one R, because otherwise it won't be a bound string. So I think just like that, maybe. Maybe just like do all the test cases, just so I'm not. So 4, 3, 1, 2. All right. Yeah, I mean, I guess I was able to do it in 30 minutes. The first one was a bit harder. I'm curious, like, what the thing is. Okay, I guess that was supposed to be easy, but yeah, well, I'm not sure, like, what is the best solution. Like, it didn't seem that intuitive to me. What is the Python 1 line? I don't know what counter does. Okay, so it basically is a histogram, so it count like so here it's saying like dot counter A0. So I guess it'll count all the, for A and A, result is the counter of the next one. So let's say you have A, B, C, D, E. A, B, C, D, E would have each have 1 in the dictionary. And then dictionary and equals Yeah, I guess easier is just to do this and then print what the results are. For my own understanding, it's like a lot easier. So it looks like he's like anding, which is the commonality. I didn't know you can and dictionaries like that. Yeah, I don't know why he did that. So what's this counter do, right? Like, it counts the characters. Bella, okay. And I see. So if I were to, so the second, so this is the first one, and then this is the and it with the label. And then, oh, I see. The first one is just and it with itself. Okay, that makes sense. The second one is and it with label. Okay, this is probably better because I don't have two duplicates. And it with itself, and it with label. And then you end it with roller, which is also 2. What happens? So I'm like, okay, I get that you end like EA in 1, but like, what if roller, like I delete 1? Does and know just to subtract it, I guess? It does. So when you and a 1 with a 2, it knows to just subtract it. I guess, yeah, my gut instinct was like to have some count of this, but I wasn't sure how to do it without like accumulating all the letters. I guess if you don't know this, then you need to do your own terminology. Like you need to implement your own counter, which the first part is easy. The ending part is hard. Because, well, for this, yeah, I guess you for each one you would make a kind of like this histogram, and then you'd go ahead and find the intersection. So for all the, yeah, that's a bit unclear to me. Like if I loop through all of the keys here and then reference it against the other, then I just subtract it, and then if I subtract it and it's 0, then I just delete that key. That's the end deletion portion. But what about like, let's say I have an extra letter here. Oh, so L exists and there's also 2. I don't, I take the minimum of them basically. And if L doesn't exist in the other one, then the minimum is 0, I delete L. So how would that work for this and Rollier? So you just do a 2 pass. So then L minus L, then you create a new counter with L of 1, and then B doesn't exist, so you delete it. E exists, and then so you take the minimum, which is a count of 1 on each, and then A would be like, it doesn't exist, so you delete it. And then you do the same R, you delete it. O. I guess you don't need to do the second pass because you're not going to add any letters here that don't exist, right? So in that case, we ended up with like L is 1 and E is 1. B doesn't exist in the other counter that we would have created. So the gut instinct was right. I guess I just didn't know how the direct non approach was. But this is a cool trick to use a counter. I didn't know you could just do that in collections. Anyway, that's the warm up. Have another hour-ish to an interview, so I'm just gonna like just chill and relax and let my brain relax, and then I'm kind of ready to go. All right.